Yeah, a quick intro. Well, Paul did our intro for us, but yeah, we're sort of talking about our own version of Wordle, but Elixir Flavour, and some of like the hidden complexities that we could never have foreseen before sort of embarking on this build. So yeah, Anna's going to take the first half and give you a bit of an overview of sort of our goals and the direction we took. And then we'll dive into some technical stuff and code snippets and a demo.
Yeah, so hello, everyone. First, we'll mention some of the goals. So the goal was to create a clone of the Wordle, which is a word game for those who don't know. But we needed to develop it in Elixir, unlike the original Wordle, which is done in JavaScript. So we used Elixir for the backend and Phoenix Liveview and TailwindCSS for the front end. And it was essentially a project that we undertook with the aim to learn the basics of Elixir and Phoenix, which was facilitated by writing tests for small parts of functionality before integrating them into the app. So next slide, please. Okay, so to understand our app, one needs to know a bit more about the original Wordle. And of course, there are people who haven't played it yet, so I will give a brief overview of its rules. So first, what is Wordle? Well, it is a simple game that is appreciated by people around the world exactly because of its simplicity, but it's also an example of an instant success story, which I will mention a bit later. So Wordle is a word game. It's hosted on the New York Times website since the 31st of January of this year, so only for the past 2.5 months. How to play Wordle? Well, the player has 6 attempts to guess a randomly generated secret word. After the player makes a guess, they will receive information about the letters of their word. The letters that appear in the secret word are colored green if they're in the same position and yellow if they're in incorrect position. So that's it. Those are the rules of Elixir explained in like 2 sentences. So very simple. But the beauty of the game lies in its simplicity. So the player can play the game only once each day. The secret word is same for each player. So it's like universal and it changes daily. That means that the players, they will not get fed up of the game, but will wish to try their, word guessing skills continuously. So they can also track their success rate in the statistics tabs that is available on the web page. Next slide, please. So now the game is simple, but it is interesting to see how its complexity increased with the advance of technology. So I'll just briefly talk about the evolution of Wordle, because I think it's important to see how something that is not really a new concept, new game, but has been turned into a $1 million deal, which I will speak about. So like 70 years ago, a New Yorker called Morten Rosenfeld invented a game called Giotto. Next slide, please. You can see Giotto here. So it was played with pen and paper, no technology much, but 2 players had to play who had to guess each other's 5-letter secret word in 20 attempts. So a player got 1 point for each letter from the guessed word that appeared in the other player's secret word. Previous slide, please. So yeah. 30 years later, this little Giotto game was adopted for television in the form of a game show called Lingo. They had an Amiga computer which would generate a 5-letter secret word and displaying only the first letter. So okay, you can give me this next slide, please. So the first letter is displayed, then the contestants, they had to make a guess within 5 seconds, and the letter that was guessed that appeared in the same place as the secret word was marked with the red square. But if the guessed letter was in the secret word but not in the same place, it was marked with the yellow circle. And the contestant had 5 attempts to guess the secret word. So previous slide, please. So now 3 decades later, again, another New Yorker called Welsh guy living in New York called Josh Wardle creates the prototype of the proper Wordle game. He takes probably elements from the Lingo game as it is very similar. So he used his own name and a nice word play with it to come up with the game's name. He published the game online for general play in October of last year. So that's like just 5 months ago. And he had no wish to earn any money from it. And so he did not include any ads on it. 1 month later, his game has only 90 players, but the newspaper, the New York Times, saw potential in the game. And in January of this year, they purchased the game for over $1 million US. So the newspaper, their vision proved correct, because just 2 months into it, the game has millions of players online. Next slide. Next. Yeah, that was all about the original Wordle. Now I want to speak a bit about the planning process of our Wordle app. So our initial data flow diagram is pretty similar to the final version of the application. During the development process, we had to make a few adjustments, which delivered more logical workflow, better user experience, I think. Next slide. This is the same data flow diagram, just zoomed in a bit. So in the initial state, you can see here that we start with an empty board. The player then inputs a word, which goes through several checks. The word has to have 5 letters. So if it is shorter, then in our application, the player can't execute the submit command to submit the word. So this error that we have in the DRD is actually, it's not used because there wasn't like a need for it, since we thought that you can see, the player can see that there are 5 cells in a row, which indicates that 5-letter words are needed. Then another check if the word has 5 letters. It's checked if it's in the dictionary again. We didn't use this error message because we just decided to mark invalid words with red letters, which we think it's self-explanatory. You can use the next slide. Yes, thank you. So if the word is in the dictionary and matches the secret word, then a win message is displayed. Next one. And otherwise, if each letter of the guessed word is checked and it's colored gray, if it's not in the secret word, it's colored yellow if it's in the different position in the secret word, and it's colored green if it's in the right position in the secret word. And this is where the trickiest part of our coding process was, when we had to check multiples of the same letter, and Theo will go through that a bit later. Next one. So finally, if the player did not guess 6 times and did not make correct guess, the game will continue the same way, goes in a loop. But if the player made 6 incorrect guesses, he gets a game over message, and the win message is displayed if a correct guess is made on the 6th try as well. So next one. And that's about it. So our Wordle app is not much different than the original Wordle. We kept the best parts of it, which is almost all of it. We did take inspiration from some versions of Wordle that appear online, like Quordle and Octordle and Sedoctordle and stuff like that. So the differences that appear between our app and the original Wordle is that our invalid word appears in red letters. We don't display error message for shorter words, and we don't have the high contrast mode, I think, yet. No hard mode yet, and statistics are probably going to be coming up in the future, and we don't have still the option to share the results. So yeah, the overview and the walkthrough of the code that Theo will go through of our version of Wordle will show that how this simple game is actually quite complex under the hood. So Theo, you can take over now.
Yeah, cool. So I wanted to start by talking about like a couple of very specific challenges we ran into outside of the usual challenges you run into when coding in a new language for the first time. So quick thank you to Josh and Martin at Alembic for helping us with this app. Something they've been drumming into my head since then is the separation of concerns in an app. So it took a while to wrap our heads around how we needed to separate our data into its different modules and keeping it all relevant to the module that it's living in, and also separating our data from the UI layer, because we were approaching this just in Elixir to start with. And then we sort of stuck the Phoenix Liveview front end on later. You can see on the right-hand side there, we've got like a simple command line interface that we built as sort of like an interim step. And that was sort of our initial front end before we touched Phoenix. But yeah, again, that was tacked on later. So we had those layers separated out so we could simply move the functionality across. There's also this sort of notion of one-way data flow that I've come to learn is very important when building an app. You've sort of got a layer at the top that knows about all of the smaller components underneath, and that top presentational layer knows about our, for example, our modules. And then those modules have functions, and those functions have helper functions. And you've sort of got this nice hierarchy of code that's flowing in a single direction, whereas your single components at the bottom don't know anything about the presentational view above, which is part of why separating those things is so crucial to being able to swap out the front end so easily. We also found out that char lists are really, really weird in Elixir. So prior to this, I don't think any of us that worked on this had much experience with char lists in any language. But for those that don't know, when you write a char list, it sort of returns the value of the char list as a list of the letters ASCII codes. So there was a lot of conversion back and forth between those and their string versions, and that was really difficult to sort of wrap our heads around. It involved a lot of logging to the console to make sure we were getting the right thing back and making sure that we were presenting the right thing to the player so that they weren't just presented with a random list of numbers. So that's some of the key things that sort of we bumped into, but there was one really, really sticky bug. And we had a laugh about this because a day or two after we discovered this bug in our own application, the YouTube user 3blue1brown discovered it in his application that he had built in, I believe, JavaScript, the exact same bug. So big credit to 3blue1brown for some of the following screenshots, because I've taken his diagrams. They show some really nice, elegant examples of the issue. But basically, I was playing our version of Wordle with my partner one night, and this sort of edge case slipped through where our guess was saying that we had guessed an E and it was in the right position. And we guessed 2 E's in our guess. And the other one was grayed out when really it should have been yellow because there was another E in the word. The game just wasn't accounting for that yet. And you can sort of see this illustrated really well in this YouTuber's diagrams here. So if the player is guessing the word speed, for example, and the answer, the secret word is abide, and they've guessed the 2 E's in the 3rd and 4th slots, one of the E's should be yellow because there is an E in that word and it's a partial match. It's not in its right position in the guess, but it is in the word. And that second E should be grayed out because there is no second E in the secret word. Furthermore, if you've got, say, two E's in the word, like we've got with crepe, down the bottom, and you guess speed again, that middle E in the third slot is in its correct spot, so it should come up as green. The second E in the guess needs to be yellow because there is a second E in that word, but it's at the very end of the secret word, not in that fourth slot. So this sort of like color coding becomes really important to how you play the game, and the user is like relying on this to be able to get all the information they need to correctly guess to the best of their ability. So that was pretty crucial. And our game wasn't doing that. Our game was doing this. So for example, with speed and abide again, if you've guessed speed and there's two E's in that guess and neither of them are in the correct slot, they're both coming up as yellow. So you think there's still two E's in your secret word, but really it's just reading that E as a partial match twice over. So that's a real issue because you're obviously going to try and guess words with two E's in them and you're never going to get abide because it only has one E. And that can really derail the game. So we obviously have to fix that. And the approach we took is that we had a pool of remaining letters that were from our secret word. And as we iterated over the letters in our user's guess, we would subtract any correct or partially correct letters from that pool so that any letters that were further assessed were correctly assessed against any letters remaining in the secret word rather than all possible letters in the secret word. So you can kind of see here a little bit of the function that we've written. It relies on this compare letter helper function, which I'll show you on the next slide. But the sort of overview is that this correct pass function that we've written takes in the player's guess and the secret word. So the secret letters you see there, the secret letter char list is created. So it converts the secret word to a char list. And then it also converts the player guess to a char list and it zips those together with the zip function. And for those that don't know what that does, it basically takes them and it pairs them up into their own neat little packages so that we kind of ended up with this really nice set of pairs of corresponding letters that were able to be like attributed to each slot in the 5 slot word boxes. And then we kind of reduce over them with this compare letter function, which we've got on the next slide. And basically we had one of these for both checking correct letters and for checking partially correct letters. All of our letters were defaulted to incorrect initially so that we only had to change them when they were correct or partially correct, or incorrect was kind of the default state. So we've got our compare letter function here, which takes in each of those letters, one from the player's guess and one from the secret word. It takes in the result. So we have 3 possible results. We've got incorrect, which is your default. We have partial, which means the letter is in the word, but the player hasn't guessed it in its correct slot. And we've got correct, which means they've guessed it correctly. It's in its correct slot. The player knows that that must be where the letter lives in that word. And basically, we're checking to see if the letter has been assigned as correct. And if it has, then we take that letter away from our remaining letters pool. So any further letters are then only assessed against remaining letters and not reassessed against that letter that we've already confirmed is correct. That's where our code was screwing up. It was assessing these letters twice against things we had already confirmed were correct and should be dismissed. So it kind of sounds simple when you say it out loud, but it was probably like a 2 or 3 day fix. I can't quite remember. And it was a real pain, but it was very satisfying to solve. So then we do that again for, our partial letters. It's essentially the same function, but it deals with the partial matches. So now that you've listened to both of us ramble for long enough, let's play a game of Wordle. Turn your mics on, get ready to shout out some guesses. Before I do start playing, I'll just show this word validation that Anna was talking about earlier. So if you type in an invalid word, it tells you by making it look all yucky and red. So, would anyone like to shout out an initial guess word?
I think you know what mine is.
Which one though? You've got like 3 go-tos.
I only use one. The French one. Adieu.
Let's start with the Jew. Okay, we've got knee. Any contenders? Let's go. I'm not looking at the chat, so I should probably open that up.
Christina says empty.
It can't be empty because we know that E is in the second last slot. Scott says speed. Let's try speed. Okay, we've still got 1 E. That's all good.
And it definitely couldn't have been speed because the D was already used up.
You're correct.
The amount of times I've done that.
I know, every day. Every day. Now's the hard part, is thinking of guesses.
We haven't eliminated an O. And
that's true.
If it's not ED, then it might be ER. Worth a try. So something cover. With an O and an R in it.
What did you say, Anna?
Cover.
Cover. E-E-R, yep. Okay, getting there. Vowel. That's a good one.
No.
Oh, what? We just eliminated V.
We don't have partials yet.
Yeah, that's tricky. Normally we've got partials by now, which is fun.
Vowel.
Vowel?
Yeah.
Charming. Okay, we've got Nell.
It uses a bunch of letters that we haven't used.
What about as a fallback, we do have like all of the game state logged out underneath this, so we can peek if we need to. We had that for debugging, but it's still kind of there. So
fall.
Something with Y or T, maybe.
Yeah, I reckon it might be like an EY or money. Yeah, that's a good one. Oh. Okay, so we know we've got an L and we know we've got an M.
We needed to use both L and M, right?
Yeah, that's correct.
So Theo, you can mention that the priority, if green appears and then we put it in incorrect place, it still keeps the green state in our keyboard.
Yeah, so that is something that we also worked out sort of towards the end of the project, is the keyboard always shows the most correct version of that letter that you've guessed. So if we've got a yellow O and a green O, it'll only show the green O, because obviously I've only got 1 key on the keyboard. So that's also how the actual Wordle works. I think Golem is possibly correct. Let's try it.
Golem's a good one.
Bam, well done. Who said that?
Scraped it in.
Well done. Cool. So yeah, you can see down here, we've got like our game state, which it might be a bit interesting for you guys. So our game state is basically a struct, and it's got a list of all letters and their state. We've got a current guess. So when the player like types in a guess, that gets filled out, and that's what gets compared directly against the secret word. We've got a list of guesses, which are a list of key value pairs showing the status of the letter and its like actual value, like the string. Our win message didn't get carried over to the new repo, unfortunately. We did have win and lose messages, but they need to be re-implemented. We've got our max number of returns. So we've sort of built this to be a little bit more flexible in case we wanted to have something like Octordle, where you've got 8 different games of Wordle going at once, which is a little bit extreme, but yeah, we've kept it kind of flexible in that sense. We've got our remaining letters. So these are all letters that haven't been sort of disqualified, I guess. So all of our letters that haven't been found to be incorrect. So this includes things like E, which we know is a correct letter. It's still a valid letter because it's in the word. It sets the secret word at the start of the game. So when the game is initialized, you can either manually pass in, if you're running it on the command line, you can pass in a secret word, which is really handy for testing. Or it'll default to the actual official Wordle secret word dictionary, which I grabbed online. And that is sort of like a set list of some fairly common 5-letter words in the English language. Interestingly, the guesses dictionary is significantly larger and contains a lot less common words. So you can have like a really obscure 5-letter word guess that will never, ever be in the dictionary, but sometimes that gives you enough information to solve the game. So it's sort of about tactical stuff at that point. And then you've got a turn state. So the player has either won the game, lost the game, or they're in a continue state and it lets them take another turn. Yeah, that's kind of it. I'll stop sharing because that's about it. But yeah, thanks for listening, guys.
Awesome. Thanks so much, Theo and Anna. Has anyone got any questions they want to ask? If so, it'd be great if you could turn your camera on to ask the questions. Or feel free to unmute yourself and do so.
Ideally.
Oh, Janko, you're muted. We can't hear you. Actually, you're not muted. We just can't hear you. All right. Does anyone else want to ask a question while Janko is sorting out his sound issues?
Can you hear me, guys?
Oh, yeah.
Yep.
Cool. Just and apologies. I was mentioned good
Sorry, Scott, you're breaking up a lot. I'm not quite sure if there's connection issues on your side. If possible, maybe it might be worth writing your chat into writing your question into the chat, and then we can answer it there. Sorry about that. Does anyone else want to give it a try? What was one of the coolest things about Elixir that you learnt doing this exercise or writing Wordle? And I guess that question can be to both of you.
Well, I personally have fallen in love with pattern matching, and I think like we got pretty extensive experience with pattern matching through this, and obviously that's at the core of Elixir, but coming into it as a newbie, coming from a background of like Microsoft development, it's a very, very cool feature in a language that makes life so much more enjoyable when you're writing code.
Yeah, I would say that introduction to functional languages was very, very, very nice to see how it's done differently and kind of makes more sense than object-oriented. So.
All right, cool. So Janko and Scott have put their questions in the chat, so let's ask them. So how do you handle the opposite situation where the word is with 2 E's and the guess is with, say, 1 E? So for example, with where the secret is steal and the guess is pears.
Yeah, that's a good question. So basically the way that we've got it working is it loops over each letter in order. And in this case, if the secret word was steal and the guess is pears, the second letter slot is a T in the secret word and an E in the guess, but there is an E in the secret word. So you would end up with a E in your guess would show up because it's not going to show you the secret word. And your guess would show up with the E colored as yellow because it's in the word, but it's not in the right spot. So you can then sort of ascertain its position from there.
Yeah, it's kind of easier in this case because it just checks one letter against two. So if it's correct, it's just correct. If it's incorrect, it's incorrect. So this is the more simple solution than the opposite.
So your follow-up question is, isn't it proper to display second in green and third in green? It would be if there were more than 2 E's in the guess. So for whatever reason, you have 3 E's in a word, it would then have, I can't think of a word with 3 E's, but okay, here's one. Slut. Yeah, so we're not showing the secret word steal. We're not showing the player that because we're only showing them back their own guess. Otherwise, like they'd just know the secret word straight away. So the secret word never shows in slots, basically. So you sort of don't have to account for the coloration of the secret word. It doesn't really have letter statuses. It just kind of exists as a char list. And then you're just directly comparing whatever the player's guessing against it. So that made it a lot easier on our end, which is good.
Cool. So Scott's question was, it looked like a good opportunity to use some property testing. Is this something that was considered?
Yeah, it was actually. So Martin actually spoke to us about it in like maybe our second or third week of developing this. And I was like, wow, that's a really cool concept. This could potentially be like a really good vehicle for it. It's just something that I feel like we sort of didn't dive into.
Yeah, just on the surface. We used it a bit. I don't know if
we didn't really use property testing, but it's definitely something I'm interested in trying. And
maybe
I think
we didn't
like
continue with that code. We deleted then.
I'm not sure if you did property testing while I was away, but I don't remember doing property testing.
No, not away.
Okay. But yeah, I think Wordle is kind of, I was talking to Josh about this, and it's one of those like really cool sort of things where you've got this very encapsulated bunch of code with very specific inputs that would be perfect for property testing. Yeah, I reckon it'd be great to be able to do that at some point.
Any further questions?
Yeah, I've got a question.
Yeah.
What didn't you like about, what was the least cool thing that you learned about Elixir?
Char lists. Char lists are annoying to deal with when you're trying to present a string. But like they're quite interesting. But they're a real pain to sort of reinterpret for the user because you're sort of doing all these operations on char lists and their ASCII values and then spitting out a string at the end that's actually human readable.
I didn't like pattern matching actually.
Really?
Can't
That's
say
almost,
that.
that's almost heresy.
Heresy. Why didn't you like pattern matching?
It was first examples I got about it were different than when I had to use it probably. So in my head, it got kind of stuck in the wrong way, let's say. So I probably got the wrong idea about it in the beginning. And then it was difficult to switch to it, to understand it in the proper way.
Scott came along with another question. Will you be making a Wordle guesser?
I feel like that it could be a fun side project for sure. Don't know whether that would be like using the official Wordle dictionary because it's actually changed since the New York Times bought them and I haven't been able to find the new word list. So yeah, could be a fun side project.
I haven't looked. I wonder if they obfuscated the dictionary this time.
Well, I know Ouija isn't valid anymore, Josh. So one of your faves has been knocked out.
Oh, that was only a favour, a very short time. J doesn't really come up a lot. In fact, I don't remember a J ever appearing in any game I've played.
I did have a follow-up question. You mentioned char list a couple of times. Was there any reason you had to use that, the two char list, as opposed to code points or graphemes?
I sort of, char lists were kind of the most accessible, I think, for us as newbie Elixirists. Basically, the way we approached it was just taking a string guess and splitting it into its individual characters. I don't really know enough about graphemes to sort of like answer that properly, to be honest.
Just means you could do French or Swedish or any other language that has more funky characters in it, or Chinese even.
We could do French, Wordle.
Yeah, but since we used the English dictionary, it wouldn't make sense to use anything else.
There was a Cyrillic Wordle or Russian Wordle, right?
Yeah,
I think so.
there are many languages, but they probably use their own dictionary and
I think
would
that's
not
where
be Charles then or something.
that's where char lists wouldn't quite work.
Yeah.
All right, cool. Any final questions?
Yeah, Janko just asked another one.
Oh,
So he's saying the slot marking the guess is peels and the word is steel. So yes, the second E would be green because it's in the third slot in the right position. The first E in peels would be yellow because it's in the wrong position, but there is one and it's there.
Yeah, S and L would also be yellow because they are in the word, but not in the right spot.
Because it will check first for the correct ones, then it goes to the partial ones.
Yeah.